And hello, welcome YouTube to this video. So just want to make sure that something is corrected. You can see that this object here is kind of I accidentally kind of just put all the entire file path here, which is not what I wanted. And if you take a look at the actual let's see, the actual object here, it should just give the word P or the word U. So we'll need to edit some of that before we continue. Okay. I mean, other than that, it's a very beautiful file. Because I mean, we made it, and okay, I was showing it to you. But other than that, yeah, we need to ensure that things are correct. Okay. So let's see. File name is file name. Okay. The object here will be okay, so write foam file section. Write foam file section. Okay, this is the file name. Okay. Let's see. Yeah, I will need to actually specify two things here. So yeah, we will have to do something. So I will need to give an extra, what do you call that? File object name. Okay, I will need to give an extra disclaimer here, or not disclaimer. This will need to be the object name of this object. So which means I want to specify this name over here. So that will be the object name. So we will put that over here. Write foam file section. Object name is just U equals to U. And you can see this code is getting more and more messy by the minute. So I think I might want to start tidy things up. And grammar error. Okay, now let's see whether this thing works. And looks like this thing is still a bit off. Oh, because I forgot to change the object name here in the write foam file section. So I change this to object name, and that should be fine. And this will now print the correct output. Alright, so that's just an error correction, and then now we can move forward with the video. So now we notice that if we start writing a lot of functions like so, you'll see that the file getting more and more messy. For example, you look at this thing here. it will have a lot of entries that are needed. I don't really like this. It's very messy to me. I might change this later, but what's more immediate is to change the way, I guess, demonstrate it by changing the way we write patches first. So for example, this write boundary field over here, write patches here, it actually requires some entries like a patch type. Okay, let me bring this down, it's a bit distracting. We will have a patch name, a patch type, and a patch value. Okay, so how are we supposed to do this? We can do get and set functions to change the patch type, change the patch name, and change the patch value. Okay, so I'm going to do get and set functions for the patch type, patch name, and patch value. Okay, so let's see. Def set patch name, self patch name, and self.patch name equals to patch name. Okay, def get patch name. So this will get and set attributes. Return self.patch name. Def set patch type. So you can set your entries here. Patch type. Self.patch type equals to patch type. Def get patch type. Self return self.patchType. Yeah, so we have the patch name, patch type, and then let's set patch value. Self. Then we'll have a patch value here. Okay, then we'll have self.patch value equals to patch value. Def get patch value, self patch value. Okay, self, I just need the self here. Return self.patch value. Okay, so this with this get and set functions, we should get maybe find it slightly easier to get this patch values. Okay, so yeah, let's do it with the right patch first. Okay, so right patch will be here. Patch type will be fixed value, fixed name, everything over here. Now I don't want all of this. I want to delete all of this. All right. So file name is file name, of course. Then we'll have a self.get patch name. Okay. We'll use the attributes that we have set. So we'll get patch type, and we'll have self.get patch value. So this is using the attributes we have in the right patch section. So let's see over here. So all this have to be set before writing the boundary field, and in fact we will not have the patch name anymore. All right, so we'll have this so-called, I guess we'll take this out because this won't be important anymore for the time being. Okay, and then we'll use the attribute setting method, self.set patch name inlet, self.set patch type, fixed value. Okay, self.set patch value. What will be this? Uniform 1. Well, 1 1. Maybe 0 0 1 in the positive z because it's going upwards. So that's the first part. Maybe that's for velocity, for all you know. Okay, so that's the boundary field for that. So this is just an example. I'm not setting it fully yet. Self.set patch name outlet, self.set patch type, fixed, well, 0 gradient. That's what I want. Self.set patch value, well, nil. Okay, so I want, because usually there's a little bit of a problem here. This 0 gradient here doesn't need a patch value. Of course you can assign a patch value, but it's kind of redundant. So I want to have this part where it sets the patch value to be nil. Okay, set patch value. Okay, or maybe I'll just set nil to be the default. Okay, nil. Set patch value equals to nil. Okay, if patch value equals to nil, then I will just pass. Okay, and then it won't do anything. Oh, okay, this is okay, wrong place to do this. Maybe I'll put it over here. Right patch value. Okay, if patch value equals to nil, then I will pass. I will not do anything. Right? If patch value equals to nil, then I will just pass. I'll not do anything. Okay, so that's the way. I hope that works. And then the wall will be like so. Self.set patch value patchName, sorry, patchName is wall self.set patchType. I'll just call this no slip self.set patch value, and then I'll just have nothing there because it will set the nil entry. Now let's try this, because this will just give you the velocity file, and then we'll just have a nil here. Okay. Well. Oh. Okay. Let's see, how do we exit out? This is kind of a bit, yeah. How do we exit out? Okay, so it looks like, okay, after looking in Stack Overflow, you can just do this thing called return none. So that's one way to exit out of the function, return a none object. So let's do that. Return none. In here, write patch value, return none. Okay. Alright, let's try again. And yeah, this is exactly what we want for velocity. Now this is a complete velocity, velocity kind of file. It is able to run. However, right, for pressure, this isn't what we want. Okay, all this doesn't apply for pressure files. So there will need to be a little bit of tweaking for that to happen. And so we may need to do some kind of a jumping through hoops or what have you. So just bear with me for the time being. So the tricky thing is to write this boundary field, right? Because one thing is that I want to write, I sort of want to write patches, and yeah, the file name given will should determine what kind of values we give in. So this is obviously for velocity, and for pressure we will need something else. So how do we set it? Okay, so one idea I have is to combine set all of these values into a file. For example, the inlet file, all the inlet boundary conditions should be put into a file. All the outlet boundary conditions should be put into a file. All the no slip conditions should be put into a file. So let's try that. Okay, let's try that. So here is the setting. I will call this 1, 2, 3, 4, 5. These are functions to help set the right boundary conditions. All right, 1, 2, 3, 4, 5. And then I'll have functions to set boundary conditions. So okay, we'll get this out of the way. It's a bit distracting, but yeah, let's do some set boundary conditions. Okay, so maybe I'll have one called set inlet boundary conditions. So you need to program this in. Set inlet boundary conditions. Okay, set inlet boundary conditions, self, I guess this will just be self, right? Oh, and then I will need to have object name. Object name. Okay, what's the object name? You'll see shortly. Okay, so I will have a few scenarios. If object name equals to u, then the boundary conditions will be for well, u, yeah. Okay. So this is what will happen. The patch name will always be inlet. Self.set patch name. Well, I can also put a patch name here, but by default it will be inlet. Inlet. Self.set patch name equals to patch name. Oh, okay. It shouldn't be equal to patch name. Let's see. One here, one here. Self.set patch name to be inlet. If the object name is velocity, I will just set this 1, 2, 3, 4, 5, or 4. 1, 2, 3, 4. So this will be it. So maybe you will just have a bit of inlet velocity. Else if object name equals to pressure, for example. Then I will set it to self.setPatchType, 0 gradient, self.setPatchValue to be, well, I don't need anything, right? So this is a set inlet boundary conditions. I will set the object name to be U. Okay. And then we will have the object name here. Object name entry equals to U. Alright. So okay, maybe I'll have object name to be here. Alright. And then I will just do this. Def right boundary field, or maybe I'll write boundary field U, self file name. Then I will call the function self dot right boundary field, file name equals to file name, object name equals to U. So there's less input we need to put in for ourselves. And then boundary field U will be placed over here. Boundary field U. Okay, and maybe I'll just I'll put the file name to be this self.getFilePath plus U. Then this should make it a lot easier. Then I don't have to write anything else here. Alright, so now it's properly wrapped. Okay, so boundary field U will just be like so. Now this is a lot nicer to look at, right? I hope you agree. But I mean, I like it. So if you don't, too bad. Yeah. Then I will have this right boundary field P. And then I will just change this to the pressure, okay, and that's it. So again, I'll have this right boundary field P. Okay, right boundary field P, that will be it. And again, there are always better ways of doing it, but for now I will leave it as such, then we'll just iterate our way up. So this is how we have the right boundary field P and the boundary field U. So yeah, so this is the set patch name, set patch type, set patch value, and I'll have this thing called set inlet boundary conditions, and I'll have the object name and patch name over there. So I'll just replace this bit of code with this set inlet boundary conditions. Alright, self.set inlet boundary conditions, object name equals to object name, object name equals to object name, and I'll just delete all of this. Okay, so this will help to set the boundary field. Now hopefully this works. Okay, it appears the inlet is 0 gradient for pressure. It is fixed value. Oh, it works beautifully. So now we can use this template to write however things we want. We can set the outlet as well. Yank. Now paste it here. Now I'll change the inlet to outlet. Okay. Outlet, and then what's the outlet boundary conditions? Well, if it's velocity, I just want it to be 0 gradient on the outside, so I call this 0 gradient. And then for pressure, I want it to be a fixed pressure, maybe 10,000 pascals or something, I don't know. fixed value of 10,000. Okay, set uniform 10,000. Okay, so let's do uniform 10,000. Uniform 10,000, and this will be the set outlet boundary conditions bit, and we'll see the patch name to be outlet. Okay, so let's go up and just do that. Okay, set outlet boundary conditions. Set outlet boundary conditions. Okay, object name equals object name, of course. And then let's try running it. We should be able to get the right one. Okay, I mean the indentation is slightly off, but well, if it's okay, it's okay. It's still C++ readable, so that's fine. Now let's do the last one for the wall. Yeah, we'll do the last one for the wall. This is laminar flow, so it should be pretty simple. Of course, you can do one example for turbulent flow as well. But I think once you have the same principles, it should be fine. Okay, so this is set wall boundary conditions. I will set this to the wall. Okay, for velocity, I will just have no slip here. No slip. The patch, the P will be 0 gradient, and nothing else. Okay. Because the pressure at the wall will be the pressure at the surface of the wall. The pressure, yeah, Newton's third law. Okay, pressure exerted by liquid on the wall is pressure exerted by wall on the liquid, so there should be the same pressure exactly at the wall. Okay, so this is the wall boundary conditions. So I will change this to set wall boundary conditions. Self.set wall boundary conditions. Object name equals object name. Okay, and again, you see this thing is a little bit messy, but it's fine. Yeah. All right, so let's see. This is yeah, this is fine. Object name should be object name. Yeah, let's try again. Okay, we have no value here at the 0 gradient. So let's go to the 0 gradient part. Set wall value. I think that's where the error is. Where's the set wall boundary condition? Oh, I put an empty string down there, so I should put it as like nil, literally, no entry. Okay, let's try again. And see, yeah, now we have a wall to be 0 gradient, inlet to be 0 gradient, outlet to be fixed value. Okay, so you see we have now a complete set of input files, all generated by Python. Beautiful. Okay, so I'm very happy with this anyway. So if you look at pressure, we take a look. The formatting is so beautiful and nice. I guess you want to add the last bit, may or may not be necessary. It's that outro. Yeah. So the outro is just this line of things down here. So just one space and this line of things. So just to polish things up, I'll have the input output. I'll have a print outro. Where's the print header? Print right header. Okay, so this is a header. Maybe I'll call this right outro, right? I'll just do this called right outro. Def right outro. Self file name. Okay. And then I will just do this. This is the outro. Yank, undo. Yank this, and then I'll paste this here. And I will just write this. The first line will be a space. The second line will be all this thingamajig here. So I'm going to use visual, and I'm going to yank this and I'm going to paste it in. So yank. Suppose these are just C++ comments, nothing too interesting. And then I'll just delete this white space here, and then that's it. Right outro, and let's go up, and we'll put the right outro over here. Self.writeOutro. Self.writeOutro. File name equals to self.getFilePath, or maybe self.getFilePathU. Hopefully, maybe I'll use the new functions. Okay, I'll paste it here. Self.getFilePathP. Right, and here we go. All right, now we have a nice thingy at the back. Actually, do we need extra space? No, we don't need extra space. Okay, so let's see the outro. All right, outro. Okay, I'll not give it the extra space then. Okay, so yeah, so now it's exactly what we want. Okay, very happy about it. Yeah, I went a bit long, but yeah, bear with me. Yeah, so see, our velocity file has all these nice patterns, everything in. The foam file is correct. Everything looks good. Okay, so of course we can polish the way we do it with Python and all, but other than that, yeah, everything looks fine. Thanks for watching. I'll see you guys again. Bye bye.